In this video, we're going to talk about solving exponential equations. Now, I should mention that most exponential equations you cannot solve using the following fact. This fact is only going to apply in very specific situations, but when you can apply it, it's pretty easy to use. The fact says that suppose a is a positive real number and a is not equal to 1. If a to the u is equal to a to the v, then u is equal to v. Okay, and that sort of makes sense. In fact, you can see that in the next example, part A, 10 to the x is equal to 13. Well, what's x going to be? Well, x will equal 13. Okay, 10 to the 13th power is equal to 10 to the 13th. That's very easy. Okay, next example, similar type of thing. 4 to the 2x plus 1 is equal to 4 to the 14th power. Well, this means that 2x plus 1 will have to equal 14. If we subtract 1 from both sides, we get 2x is equal to 13, and so x is equal to 13 over 2, right, or 6.5. Okay, these are pretty easy to solve. Notice that in order to apply a fact here, the base has to be the same. This is 4 to some power equals 4 to some power. When we use the fact, it was a to the u equals a to the v. It has to be the same base on both sides. Okay, part C, e to the x squared is equal to e to the minus 8x minus 15. So x squared is equal to minus 8x minus 15. If we add 8x to both sides and we add 15 to both sides, what we'll end up with on the left side is x squared plus 8x plus 15 is equal to 0. And we can factor the left-hand side. It will be x plus 5 times x plus 3. And notice what values of x will make this true. Well, if x is negative 5, the left-hand side will be 0. And if x is negative 3. So negative 5 and negative 3, those are both solutions. And you can check them up here. Negative 5 really does work, and so does negative 3. Okay, part D, we have 5 to the x minus 4 is equal to 125. Now notice, in order to apply the fact, we needed to have a to the u is equal to a to the v. The base had to be the same. Notice we have 5 here. We have 125 to the 1. But actually, we can rewrite 125 as 5 cubed. So 5 to the x minus 4 is equal to 5 cubed. Well, that means that x minus 4 would have to equal 3. Adding 4 to both sides, we'll see that x is equal to 7. Okay, and you can check that for yourself if you plug in 7 for x. 7 minus 4 is 3, and 5 cubed is equal to 125. Okay, now this worked very well when we had 5 to the x minus 4 equals 125. What if we had 5 to the x minus 4 is equal to 137, let's say? Well, in that case, we're kind of stuck because we just got lucky here that 125 was 5 to some nice power, right? 5 to the third. But 137 is 5 to some messy power. So how would you solve something like this? Well, we're going to have to use something different, okay? And we'll in our next video, we'll talk about how do we solve something like this. Okay, and the last case, last example, 8 to the x minus 4 is equal to 32. Now notice 32 is not 8 to some power, but actually 32 is 2 to the 5th power. And 8, isn't 8 2 to the 3rd power? So we have 2 to the 3rd power to the x minus 4 is equal to 2 to the 5th power. Now we can rewrite the left-hand side using properties of exponents. This is 2 to the, now remember you multiply. 3 times x minus 4, but that would be 3x minus 12 is equal to 2 to the 5th power. Okay, now 3x minus 12 is equal to 5, according to our fact. If we add 12 to both sides, we get 3x is equal to 17, and dividing both sides by 3, we get x is equal to 17 thirds. Okay, and you can check on a calculator. If you plug in 17 thirds in here for x and subtract 4, then raise 8 to that power, it will equal 32.